Okay, so we'll get started. So I hope everybody is in the right room. This is a very boring topic as far as I'm concerned, but I've been doing this for a while, so it does get boring talking about it. But I'm hoping that everybody's here for a talk about practical OpenTelemetry. Is this anybody's first introduction to OpenTelemetry? Has anybody not seen or used it? Oh, you're in for a treat. Yeah, we've got a few more people coming in, so if you can just move to the sides a little bit and let people come in, there's some space at the back there. Awesome. Thank you so much. It's fine, thank you. Okay, so I actually did my first talk post-pandemic here around the same subject. So if any of you were here, I apologize, I was out of practice. I'm not now, so hopefully this will be better. So, who am I? My name is Martin Thwaites. I'm first and foremost an observability evangelist, and we'll talk a little bit about what observability is. I'm also a developer advocate for a company called Honeycomb, who develop observability products. Today, I'm not here to talk about Honeycomb. I'm here to talk about observability in general, but also about specifically OpenTelemetry and how to use it. OpenTelemetry has been around for quite a while. However, it's now getting to a point where people don't want talks on how cool it is. They want talks on actually how to use it in their applications. What should they be doing? What shouldn't they be doing? And that's really what this talk is about. So, we can't really talk about OpenTelemetry without really defining why it is that we're doing it, what observability actually is. So observability, this is a quote from Charity Majors, who's our CTO, who started the movement around observability in software around 7 years ago, who describes it as understanding and debugging unknown unknowns and the ability to ask questions. That's really what observability is about. It's not about 3 pillars, it's not about logs, it's not about metrics, it's not about any of those things specifically. It's about asking questions. It's about the ability to ask questions. So, what sort of questions? Well, things like, what's the impact of my change? Is the code that I just wrote being used? Is this feature being used? Has the time of any of my user actions changed? Cross-region latencies, third parties, all of that sort of stuff. It's about being able to ask those questions. How are these things doing? So why does it matter? I mean, we've been writing software without this idea for quite a while now, I would assume. I won't reveal how long I've been writing software without this, but it's been a while. So why does it matter now? I don't know about you, but as an engineer, I feel overworked. I always have done. And now we're asking engineers to ship more often. We're asking for daily deployments. We're asking for per commit deployments. We're asking for every hour. It's no longer in this cycle of doing 6-month deployments. You know, we do 2 deployments a year. Make sure you get your code changes in. We're asking this to be done regularly. But while we're doing that, we're also being asked to write better code. Like, not the stuff you were writing before. No, it needs to be better now, and you need to ship it more often. Okay, great. Oh, but can you also spend less time fixing bugs as well? Like actually writing features. So you need to ship it more often, make your code better, also spend time fixing less bugs. Great. Okay, but can you also make sure we don't have downtime as well? It's like, there's all of these things that we're being asked to do, and we can't ask engineers to do more things without giving them better tools, without giving them the ability to do these things better, faster, more often. So that introduces us to OpenTelemetry. What is OpenTelemetry? We've had telemetry things before. We've had APM tools, so application performance monitoring tools. The big vendors have been out there doing this sort of thing for quite a while now. So what is OpenTelemetry in this space? Now, first and foremost, OpenTelemetry is a protocol. It's not something we install. There are SDKs. But first and foremost, it's a protocol. It's how do we get telemetry data that we produce in our applications to a vendor backend or an open source backend or a backend that you deploy. That is why OpenTelemetry is so interesting to me. Because it means that we're no longer beholden to the provider that we chose when we started doing the software. Now, if you've ever tried to move provider from an APM tool, and you've got, I don't know, even just 100 machines, never mind the 1,500 machines that some people work with, and they've got an agent from said vendor installed on all 100 machines, and then you go, great, we'd like to use a different vendor. And your infrastructure team go, ha, oh, you were serious? No, we're not doing that. Because reinstalling all of those agents, those proprietary things, is what you need to do to move vendors. But what if you didn't? What if, to be able to move between different vendors, it was 3 lines of config? If all you needed to do was change a few config lines and your new provider gets all the same data that the previous provider got. That is the promise of OpenTelemetry, and it is delivered. This is in production in lots of companies that we work with. Now, the other thing OpenTelemetry provides in order to do this is SDKs. They provide SDKs inside of your solution that produce this telemetry in a standardized way so that vendors or open source solutions can use that in interesting ways. OpenTelemetry is made up of 3 primary signals. Notice the word signals there, not pillars. They are signals, logs, metrics, and traces. In the .NET world, traces and metrics are stable, mainly because we have activity and meter inside of the code base from .NET. So yes, we can use them. Logs, the protocol is stable, but we shouldn't be using logs anyway. We'll come on to why logs are trash. We'll cover them for about 30 seconds and then move on. But the protocol is stable. That's the how do we transfer between the 2 systems. The SDKs are not, which is why when you're looking at some of these code examples, you'll see that we use the pre-release flag to install some of the pre-release packages. That's because, yes, they work. Yes, they're in production. Yes, they're running at scale. But unfortunately, the API might change based on the OpenTelemetry specifications. Now, I'm talking specifically about .NET, by the way. So those stability things there are specific to .NET. Meter or metrics is not stable in all languages. Logs is there in only Python and .NET. There are more coming up, but ultimately they're not stable. So what's a trace? We're talking about tracing first, because that's where I believe everybody should be moving towards. OpenTelemetry is not just tracing, but tracing is the primary signal that you get value from. So trace is a thing that is being done. It's not something we create. It's not something where we go, create trace. What we do is we create a span. And a span has a trace ID, and that is how we build up a trace. Because all the spans with the same trace ID are a trace together. But a trace itself isn't something that we create. So what is a span then? I'm talking about spans. What exactly is one? You can think of it as a structured blob of data. Think about a JSON blob, think about any kind of blob of data. You can think about it as a structured log if you really want. But it's a structured blob of data that has some mandatory properties on it. The first one being a unique ID, something that identifies this particular span, a span ID. It has a correlation ID. Correlation IDs, I'm assuming most people have heard of. They have been around for a while when we were doing logs as our primary signal. We call that a trace ID. But it also has a duration. Measured in milliseconds, it has a duration. It also has a timestamp when this thing started. And it has, the most interesting part, a causality ID. The thing that was happening at the time when this thing was created. Essentially the parent span. the thing that happened before. Now, having these allows us to be able to do a trace waterfall, which is what you see on the right, left. It's my right, your left, that one. And that trace view is what allows us to see how a request has transitioned through our system. What caused it to happen, what happened before. Now you may say that, well, we had this before. We had logs, we had correlation IDs, we had timestamps. And it would transition through 5 different services. And I'd see all of those sent into a centralized logging system. To that I say, when was the last time you checked your timestamps on all of your servers and your time servers across all your different microservices? Did you sync them? How far out are they? Quite far normally. What we do with causality ID is essentially stamp that between all of our services, between all of the different process boundaries. But what that is a structured log, basically with some mandatory properties. It's basically just a fancy log. The stickers for most of these images, by the way. Come and get them at the end. So if I'm telling you that's a span, what is a log then? Well, logs are designed for humans. They're not designed for systems. They're not designed for aggregation. They're designed for systems. We took logs and made them structured, but primarily logs are designed for humans, which means they're great for access logs, like your access log in Nginx or IS, the W3C access logs, because they don't have context. There's no causality ID. They're good for audit logs. They're also really good for debugging whether your tracing is working or not. I wrote an entire blog post on that. There will be some links at the end, by the way, for you to pick up and do some follow-on reading. Now, ultimately, most people are doing logging wrong. Just ask this guy. I jest. Nick is an amazing educator. He's got a talk on logging and performance tomorrow. Go see it, because a lot of the things that he talks about optimizing performance for logging also apply to using activity and spans. So go and have a look. Also look at his YouTube. Cool. I mean, mostly logs are fine, depending how much money you've got to burn. So let's get in some code. Because what we're talking about here is how to practically do things. What are the things you should be doing? So first one is logging. Now you notice here we've got the pre-release package. But it's as simple as adding OpenTelemetry to your logging builder. And then we tell it where to send that data. Now here we're using the OpenTelemetry line protocol, which is OTLP, not OLTP, because those two mean different things and I always get them mixed up. So OpenTelemetry line protocol is that protocol I was talking about how we transfer between the two services. Metrics, similar thing. Because metrics is stable, there is no pre-release flags. And the same thing, we add OpenTelemetry to our service collection. We say with tracing, and then we add the OTLP exporter. It's getting boring now, isn't it? It's the same thing. With metrics, add OTLP. Wrong way around. You get the idea. Like I say, this isn't the interesting part. This is the bit that's easy. This is how easy it is to add OpenTelemetry to your application. You're not telling it which vendor. You're not telling it where you're going to send it. You're literally just adding it like this. I don't know about you, from years ago when we used to start a project, the first 6 months of any project was deciding which logging framework you were going to use. And there were battles fought over lesser things. So, once we've set up our logging, there are a couple of things that are really important to set up. Now, we need to tell OpenTelemetry what our service is called. And we do that using something called the resource builder. Because a span is based on 2 different types of attributes. Resource attributes, which are set at the start of a process, like startup of an ASP.NET Core site, and attributes that are applied to each individual to an individual span. So here, we're using configure resource. The thing I want to draw your attention to here, though, is It's actually an extension on add OpenTelemetry for tracing of metrics. It's not within the with tracing element. It's specifically inside of that, which means it applies to tracing, it applies to metrics. Do be careful about the attributes that you add globally, because you can add extra attributes like this. If you add them at this level, they will be added as labels to every metric. There are problems with metrics, and the reason why I don't promote metrics as much as other people is because dimensionality of metrics is hard. When you start throwing lots and lots of different dimensions and lots of different values in those dimensions, metric systems tend to crawl into a corner and say, please stop, whereas traces don't. So once we've added our service, we can now add more attributes. Now these don't get applied when we create a span. So from a performance angle, this is the most efficient way to give your traces context. But they're applied to every span within that service once it starts up. So the reason why that's really interesting is because we can do things like adding the region that we deployed our service to. If we're in Kubernetes, we can add the pod name, we can add the deployment name, the service name. We can add which specific version of the application it is that we've got deployed. Because if we're deploying these things every day, you're going to be in a situation where you've got multiple different versions live. That's why these things become important. Okay, metrics. It is incredibly easy. You'll notice a theme throughout what we do when we talk about this. Everything is fairly simple. And the reason it's fairly simple is because it's not complicated. I don't know how else to say this. It's a few lines of code, but it's code that you control, not a vendor. It's code that you can decide where to put. It's code that you can decide to put context on. So when we do a meter, now we'll talk about how to set up configs in a minute. In this particular example, I'm using a static class for my diagnostic config. And at the top there on that fourth line, we've got meter equals new meter with the service name. And that's static in this class. And then we create all of our different types of metrics for that particular meter. Things like sales value, markup, histograms, counters. In .NET 8, we've now got up-down counters as well. It's actually in .NET 7, but .NET 7 doesn't really count because it's not LTS, is it? So. And then, when we've created them, OpenTelemetry doesn't know about them. So you can create them at the top there. But until you do this bit at the bottom, OpenTelemetry isn't going to listen to them. It's not going to send them anywhere. It's literally just going to run it in the background, and they'll go into a black hole. So when you create some metrics and you don't see them, check to make sure you've added the add meter bit at the bottom there. Now when we then go to use these metrics, because obviously we've just defined different types of metrics at this point, when we go to use them, it is as simple as referencing that static class, referencing the particular type of meter, and using record for histograms, using add for counters, same for up-down counters. That's it. Metrics done. There isn't that much more to it, because all of the interesting things that happen with metrics happen after your code. They happen when you put them into a backend to do aggregations. They happen in the backend when you start doing reporting on these things. It's literally just that in your code. Choose where you're going to put them. Choose your metrics sparingly. Throw labels on your metrics, but don't throw too many. Otherwise, your ops team will cry because Prometheus won't work anymore. But you can add things like that. Okay, instrumentation libraries. This is where we get a level of automatic instrumentation. Now, this is what's going to get you up to a point that you're used to with an APM tool. We got to a point with APM tools where you'd install an agent and it would give you everything. It felt like magic. We just install the thing and then we've got pretty graphs that we can put up on a dashboard and management think we're doing really cool things. We're really not. Nobody looks at them. This is what's going to get you there, because what we've talked about is manually creating metrics. Instrumentation libraries are language and SDK specific. So these are specific to .NET. They're specific to the libraries that you have in .NET. So when you've got a library like SQL Client or HTTP Client or gRPC services, you've got ASP.NET Core, you've got all of these different things. All of them will have an instrumentation library that goes with it that you can now tell OpenTelemetry to use or not use. It's important to say that this is step one. This is your getting started. This is out of the gates. Let's just put a load of automatic stuff on there. Don't stop here. So, basic Microsoft stuff, ASP.NET Core. I would hazard a guess that 80%, 90% of the people in the room are using ASP.NET Core. You can add the packages. You'll notice they're all pre-release. Do not be scared of that. Do make friends with your security team so you can explain why you're using pre-release packages. The pre-release means that the naming of spans and attributes is not defined and ratified yet. That's the only problem. It's a problem we've had for about the last 2 years, but nobody will fix it. Until we've got that ratified, those won't be marked as stable. It should happen in about November, because we've just had all of those schemas come into OpenTelemetry and now starting to get ratified, and hopefully in November that will have all happened and we can all move on with our lives. ASP.NET Core, HTTP Client, SQL Client, they're all part of the OpenTelemetry namespace. You can add them just with add ASP.NET Core instrumentation, add SQL Client instrumentation, add HTTP Client instrumentation. If you use an entity framework or Postgres, again, the same thing, add npgsql and add entity framework. You'll notice, however, npgsql.telemetry is a different namespace. And it's not pre-release because they get to choose whether they say it's pre-release or not. And they decided not to. Go figure. Redis, I'm presuming a lot of people use Redis as well, is slightly different. So Redis, when we ask for automatic instrumentation or instrumentation libraries, it needs access to something called the connection multiplexer, essentially access to the connection to add some data. For that, we can use a special extension called Configure OpenTelemetry Trace Provider. That gets resolved when your application starts, not when you register services. So it means it can use things from the service provider, it can use dependency injection. All of this is documented. There is a GitHub repo with all of this in. You don't need to take pictures. It's absolutely fine. This is mundane. This is where it gets interesting. This is where we start to think about what is our context. What is our context in our application? Because yes, most applications, you've got a database, you've got a website, you've got people hitting it, you've got some APIs, maybe it's a bit front end, maybe some microservices happening. Everybody's the same, yeah? Every single site's the same. Everybody stores their user ID in the same place in the request, yeah? Everybody has the same account object. It's all account in the database, yeah? Nobody uses customer. Nobody uses customer now, do they? Your context is important. And that is where we had a failing with APMs, because they assumed so much. Manual instrumentation is where we can add our context. Now, I need to take a little bit of a diversion to talk about span and activity. Because in a land far, far away, known as Seattle, Microsoft designed something called Activity. And it's been in the .NET framework since around .NET 2.0. Tracing has been in .NET for many, many, many years. So it's not new. When OpenTelemetry came around, There was no reason for OpenTelemetry to go and reinvent and create a new thing. There is such thing as a shim that uses span, tracer, span event, span links, and all of the OpenTelemetry technology that you can use in .NET. If you're working in .NET every day, ignore it, just use activity. Okay, slight rant over with. What is a span or activity? I'm going to use the word activity and span interchangeably because I don't see the difference. So please, whenever I say those two, span does not mean the span object in .NET, which is a completely different thing. So a span or activity is time-bound analysis. It's the idea, and we talked about what a span was, it has a duration and it has a start time, a timestamp. It's about time-bound analysis. We create an activity, we dispose of an activity. That's our duration. It's normally scoped to an individual piece of work. So everybody's got that little algorithm that they've got in their code. It's the crown jewels of their application. They spent 3 years building it. It's got 42,000 unit tests around it. It never goes wrong. So we don't need to look at it, do we? But actually what happens is the performance of that might change depending on inputs. So an activity is how we scope that around that piece of work where we call that algorithm to be able to do stuff. So an activity might be a HTTP request that comes in. It might be a call to a database. It might be a call to a third party. Those are the things you get for free with instrumentation libraries. You don't get them for free in your code, which is where you've got to add some stuff. Spans and activities are also about causality. So this thing happened before. It's about correlation. We talked about trace IDs, correlation IDs. And they're really useful for understanding complex code structures and how something takes a path through a platform. I mean, really, they're just a log, but with so much more. So how do we create them? The first thing we need to create an activity is an activity source. Now, activity sources are actually they're actually a shell. They don't really do anything. They store a string value, basically. You can create 20 different activity sources with the same name. It really doesn't matter. Don't do that. Create it once with a name. It's irrelevant, though. The name is what's important. Once we've got our activity source, we can then create activities using a function on the source called start activity with a name. That's as simple as it is to create a span. Diagnostic config .source .start activity. Now in this scenario, I'm using a static class to store my activity source. The other way of doing this is using dependency injection, if you really hate yourself, where you can inject a diagnostic config. My main piece of advice is if you are doing dependency injection like this, don't try and inject activity source. Inject a custom class that contains an activity source. Do it as a singleton, and then use that. Now there is a question I get asked quite a lot. How do I test this? I have an entire talk on that on YouTube. Go and look at it. It isn't easy, but it is doable, and it is really, really valuable when you do it. Because that isn't an interface that you can mock. And I'm using that in the MOCK sense, not the MOQ sense, because don't use that. You can tell who in the room is up to date with what's going on in the .NET community. Okay, so manually creating spans. We saw what we were doing to manually create a span there. Now here's an example bit of code. I firmly believe this is how some e-commerce sites work out how to charge people. Just do a random number on top of the category number. So the idea is here, we've got a little bit of code there that's going to change its performance based on the category ID that comes in. Because the higher the category number, the more random numbers we're going to add. So how would we do that? So what we do there is we create an activity that wraps just our for loop. We give it a name that means something. The name that we give it is what we call low cardinality. Essentially, it's a static string. It doesn't have parameters in it. This isn't a message. It's not a log line. It's low cardinality. It shouldn't change. The things that do change are the tags, the context. So when we've put this in, we've created an activity. What we've then done is we've added 2 tags. The first one being the category ID that came in, the second one being the product price. Now notice the naming convention of the tags. We namespace the names of our tags using dots. That allows us in UIs on the back end, depending which vendors you're using, to group these together under the common things. We then do all of our stuff. We then add a tag at the end, which is our new price, and then return out of the method. Now, because we're using the new using syntax in C#, what that's going to do is it's going to dispose of the activity at the end of the method. That's when our activity is going to end. Again, it's not complicated. We're not doing anything particularly advanced with this. This isn't advanced C# concepts. We're using libraries that are built to be easy to use. Now, what I would do though, that's great code. I would be happy to see that in people's platforms. They're adding context to their traces. That's great. But we can take this a little bit further. Now, we had our diagnostic config class. The next class I would advise people to make is a diagnostic names class, which contains constants. What that means is that everybody uses the same names for their tags. Now, I'd actually suggest that people go a step further than this when you're working in microservice platforms and put this in a shared NuGet package that everybody uses. So everybody uses the same names, which means you've got shared language, you've got shared context. So when you're looking at your observability in the background, you know what you're looking for. Throw descriptions on these. Tell people what they should be putting in them, what they shouldn't be putting in them. Help your developers out. And that makes it look like something like this. I don't know about you, I hate magic strings. Magic strings in .NET make code look horrible. They make it look unreadable. It also means you can't search through your code base for implementations of a thing. Help your IDE out. IDEs have feelings too. Okay. Now the other thing I see quite a lot is people wrapping the activity class. They'll create the my activity class because it creates it. It creates an activity with very special parameters that are unique to us. The problem with that is you're abstracting people away from what .NET brings with activity. It means that when you bring somebody onto your team, you've got to explain what all the new classes are. Activity is pretty common. People can use it everywhere. So just use extension methods instead. So everything is based on activity. Provide context. So what we've got here is an extension method that will start an activity with some tags. And it's just a proxy into source.startActivity. It's not a particularly complicated one. You can go a level further with this on activity. So we use the product example, and I don't actually have a slide for this. But we used the product example before. One of the things I'd suggest that people do is actually have an activity extension that says set product information, which takes a product price, which takes this information, and then makes sure that all of the spans have that information on them. Okay, activity versus ActivityCurrent. So we've used this code where we do creating an activity, and then we start the activity. Now what that does is it creates an activity, it starts it, but it also makes activity.current, which is a special property of activity, set to that activity, which means anywhere in your code base, you don't have to pass activity around. You can just access whatever the current activity is that's running and add stuff to it just like we've got there. Now you do need to be careful because that code example at the bottom is actually the same as the one at the top, unless another activity is created in the middle. So in that little space in between the start activity, well, it actually says create activity, that's a bug. If that said start activity, that bit at the bottom wouldn't actually work. It would add it to a new activity in the middle. So in an example where in the middle you're calling out to 5 different methods, which all create their own activities, that doesn't mean that you're going to use the same activity when you get back. Do be aware that if you want it to be added to the activity you've just created, use the activity. However, if you don't, and you don't care, like for instance, you're in a controller method. If you're in a controller method like that, you don't have access to the activity. What you've got is ActivityCurrent. And you can say, just set a tag. Don't care which activity it's on, just set a tag. So just know the difference between using the activity you've created and using ActivityCurrent. It's up to you. I can't tell you which one's the best one to use. Performance-wise, they're exactly the same. It's entirely up to you which one you want to use. But it does work over async context. It works through all of those things. Okay, span event. Now we're getting into the really complicated stuff. You thought it was easy at the start. You're like, oh, I'll just walk out. I know all this. So span event or an activity event. It's a point-in-time action. Something that happened during your span execution or your activity execution. It has its own context, so it has its own tags. It's very useful for, say, an exception that happened in your code during the execution of your span. But ultimately, it gets then attached to your span. And we'll come on to why keeping all of these things together is really useful at the end when we talk about sampling. Ultimately, a span event is really just a structured log, but it's a structured log that's part of your span. So a span event has its span ID that it's part of. It also has the trace ID. It also has its own unique ID, a span event ID, because you can have more than one event on a span. Timestamp, and just a list of a bucket of attributes. So one of the other ways to use it would be things like validation events. So if you don't want to add all of these extra bits of information to your current span, you can add an activity event to your current span. We're using ActivityCurrent here because we haven't passed that activity down. So you can see it's pretty much the same as we've been doing before, other than the fact that we're adding tags when we create it now, rather than adding tags as we go along. It's also good for recording exceptions. So if an exception happens, there is an extension method in OpenTelemetry that adds to activity and allows you to do record exception, pass it the exception information, it'll add an exception message, it'll add the exception type, and decompose some of those stuff. Pretty much that's the extension method stuff I was talking about when I was saying product. Because now everybody will use record exception, therefore in your backend, everybody's going to use the same names. Span link. Now we're getting really into it. Everything that we've talked about so far is based on parentage. When you create a new span, its parent span ID was the span that was active when I did it. Sometimes that isn't the right way to model your observability. Before I came into doing this sort of thing for Honeycomb, I worked for a bank. We had an event-driven platform where an interest would be accrued at midnight every day for every transaction that was created, which is fine. We get a message through. We get a transaction created goes on service bus. A lot of systems come in, do some stuff to it. Great, that happens within 5 minutes. But then almost 24 hours later, something else happens. Now, it might be that that parentage isn't the right thing, and that's where span links come in. Span links allow us to say that our new trace, our new span in our new trace, relates to another span in another trace. So we're not saying that this thing is a dependency, we're saying that it's linked. It might be a dependency. So we use trace context or span context to create these things, but it doesn't exist inside the same trace. This is how we get two traces that we can move between the two. I will caution you on span links and span events because not all backend vendors support it. The most notable example for this conference is that Azure Monitor doesn't support it. Log Analytics doesn't support it. So it's basically an alternative to our parent-child parentage stuff that we were talking about. Now we create span links, and this example here is where you might want to do this. Now if somebody sends me an order and I have to trigger an email, and then I run something asynchronously in the background, maybe I want the sending of the email to be related to the checkout, but maybe I don't. I don't know your context. No vendor knows your context. You are in control of your observability journey beyond your code when you start using OpenTelemetry. There are opinionated ways that some of this work. So with the new Azure Service Bus libraries as an example, if you enable the experimental flags, a lot of these things work for messaging and will default to parentage. But there is an option to move it to a span link if you want to. Okay, processors. 18 minutes, right. Need to. For people watching this on YouTube, this is where you go at half speed. The rest of you can do that in your head, that'd be great. Okay, processors. So processors are part of our OpenTelemetry pipeline inside of our application, which allow us to do some interesting things with spans when they're created and when they're disposed. And it gives us basically a hook. So that on start we can do something, on end we can do something. So we can do things like add in additional context. It's realistically just a middleware, like you will have used for an app builder to add, use, and then pass things through your context. However, beware, there is a performance impact. Because it runs on start, it runs synchronous. If you add a thread.sleep into a processor like that on the on start, everybody who creates an activity is going to have that sleep before their code is executed. So you need to be really careful about what you put in processors. That's as simple as they are. You derive them from base processor, and you get an on start and on end that you can override. And you can do some interesting things like, I would like the tenant ID from my HTTP request to be on every single span that's created. So I can add a processor that on start goes to the headers, grabs out X tenant ID, and adds that as a tag to the activity. And then I can add that using that configure OpenTelemetry tracer provider, same method that we were talking about for Redis before, because it can use dependency injection. So we can pass it in the iHTTP context. Now, baggage, if anybody has followed me on Twitter, you'll know that this is my favorite thing to talk about. It's commonly referred to, well, it's referred to by me as the foot gun you never wanted. So baggage is the idea that you can pass over context between your two services to influence the tracing on descendant services. Now the key there is influence. It's not passing over an attribute that will then be added to every single trace, every single span that then comes out the back end. It's about being able to say, in the back end, something happened in the front end that's going to say you need to add extra telemetry to the back end. Now, there are a lot of people and a lot of distros that add what's called a baggage span processor, which will take everything from baggage and add it to your spans. Honeycomb is one of them. I'm sorry. But I don't recommend it. All of these stuff that we've talked about, all the trace context, all of the baggage stuff, is not OpenTelemetry. It comes from W3C, and it comes from a standard called trace context. So be aware that this is dangerous. Why is it dangerous? Well, if I set, for instance, something like this, if I set baggage.current.setBaggage, and I set the user's account name on there, and then I make a call out to my inventory API, great, the account names come through. The problem is if that is HTTP client there, is actually http://evilcorp.com, they're going to get all the account names. Because OpenTelemetry doesn't know the difference between one of your internal services and your external third parties. We can do that, we can override propagation. Unfortunately, that's an entire talk in its own right, but I do have blog posts on exactly how to do that. Now, once we've set something in baggage, we can then, in our inventory service, we can go and get the account name out. By the way, everybody should have this code in their platform. We can use that baggage data and say, well, if the account name is martin.net, then I'm going to set a value that says this is a VIP. You don't have to put that in if you don't want, I suppose. But you get the idea that what I'm not doing is I'm not adding the account name as an attribute in the back end. I'm using that to influence the telemetry that I build. That is why baggage was created. That's the reason why baggage exists. However, a lot of people do this, and they write a span processor that we talked about before, so that on the end of the span, it goes to the current baggage values, just iterates over them all, and adds them as tags, which I suppose is a way to do it. Now, if you are going to do something like this, what I would suggest is at least add a filter and use a prefix on these baggage items. Because that baggage could be coming in from a third party to you. And if you blindly accept all of that data and somebody sent you over a card number, a social security number, you've just added that to your backend into all of your observability. So think about what you're adding. Custom propagation. I'm going to talk a little bit about custom propagation in terms of messaging. So propagation itself is based on the W3C context. W3C is a standard outside of OpenTelemetry. It is currently as a recommendation, not a standard. I think it takes 7 years to make it through. It makes some agile projects look, pretty fast, really, don't they? But it's an effort for us to be able to have standards between all the different languages. With OpenTelemetry, propagation is automatic. You don't need to do anything. If you add ASP.NET Core and HTTP client, the auto instrumentations, the manual instrumentation libraries that we talked about at the start, you will get this for free if you are using HTTP. If you've got an ASP.NET Core website that calls out using HTTP client to another website, all of this you get for free. However, we can use propagation in non-HTTP contexts. And if we use the standards, it will also propagate baggage. So in Azure Service Bus, this is what you can do now without using the experimental stuff within the Azure Service Bus SDKs. So when we create a message in Azure Service Bus, we new up an object called Service Bus Message, which has headers or properties. It's called application properties. And from there, we can inject into our application properties our trace context. So that message gets our trace context. And we do that by passing in the current context, passing in any baggage, giving it the message that we want it to inject to, and then passing a delegate over that tells it how to set properties on them application properties. And then we do the inverse on the opposite side. So when we get a message, we can extract the properties from those application properties, and we can use those to create our own activity using that context as its parent. Again, repos are all online. The main thing here is knowing that you can do it so that you know what questions to ask to go and find the data. There isn't an exam at the end. You're not going to be quizzed on what inject and extract is. Okay, got just enough time to do something called sampling. So I hope everybody understands quantum physics, because that's where we start. Sampling is very maths heavy, so I'm not going to go through that part. I totally understand what it's all about, but we won't go through that. Two types of sampling. We've got head sampling and tail sampling. Head sampling happens at your application level. Tail sampling happens inside of a centralized thing that we like to call the collector. And it's a way for us to retain trace context without as much cost. So it helps us reduce our storage and our ingest while retaining all of that context, that rich context that you get from them. When we do head sampling, it looks something like this. When the request starts, we make a decision. Are we going to sample this data, i.e. keep it? Or are we going to discard this particular context? Now you can imagine at that point, we don't know whether this is going to error. We don't know whether it's going to call 10 services. We don't know whether it's going to be slow. So we have very little information, which means it's a very coarse tool to be able to make decisions on. You can make decisions on, say, maybe I want to sample a small amount of my health checks because they're not really important to me. I don't want to litter up my tracing system with health checks. So maybe do 1 in 1,000, just send over 1 in 1,000, but tell the backend that there was 1,000 of them. So for every one you send through, say there was 1,000, which allows your backend to be able to extrapolate what the actual value was. Importantly, it's before activities are created that we make these decisions. It's really efficient because it removes any performance overhead of us actually doing any logging or any tracing in the back end. But the amount of information that you can use to make a decision is very, very limited. By contrast, tail sampling happens after all the spans are finished for a particular trace, which means we've got tons of information to make a decision on. Because it runs on a delay after that first span has been received in our collector. It has access to all the span data, so it's got access to how many errors happened. Was there a retry? Did it take 5 seconds? Did it take a minute? Did it take 200 milliseconds? Which systems did it call? Did it call a third party? And it can do that across the entire trace, not just on one span. It can take into account all of the information for all of the spans in that trace. But it does have the downside that it's going to delay sending of those spans to the back end. That's an important characteristic when you're looking at observability, is how quickly can I start asking questions based on my system? There are platforms out there that have a 5-minute SLA from you sending it data to you being able to receive it. Now, if you've ever been in an outage, 5 minutes is an eternity for you to know whether things are still working, which is why people end up going on the website and checking themselves. It's like, oh, it works for me. And then you realize that you're on the internal network and the firewall's down, so nobody can view it. The other thing is it requires an application to send all the spans for all the traces, all the time. So you've got a lot of data exiting your application into that. So head samplers are pretty easy. You can write them in .NET. That one there just takes a random percentage of all the spans and says, I'm going to keep this one, I'm not going to keep that one. The sampling parameters are things that you get when the activity is created. So for .NET, it should be, but it isn't at the moment, it's broken. You should be able to do things like URL, user agent, some of the headers, all of that kind of stuff. And then you make a decision, am I going to keep it or am I going to drop it? And then every descendant service that is part of this trace will inherit that decision. And that's all done using something called the collector. Okay, the collector is part of OpenTelemetry, but it's not .NET. So why does it fit into this talk? The OpenTelemetry collector is a service written in Go. And as one of my friends quite eloquently put earlier, Go is an awful language, but all the interesting tools are written in it. Now, the collector is a service that runs. It can run in two ways. It can run as a service inside your infrastructure as a container that everything sends data to. Or it can run as a sidecar if you're running Kubernetes, or both. One of the really cool things that it allows is centralizing of config. So where you're sending your observability data to might change. You might have an API key. And if you've got 1,500 microservices all sending to one telemetry backend, and your security team come to you and say, our key's been compromised for our vendor. I need you to go and change the API key for where you're sending your data. And then you watch devs cry. It's like, I'm not coming home tonight. If you centralize your config with the collector, if you have all of your applications, all of your .NET microservices, all sending their data to one collector, and that collector then forwards that data onto your backend provider. When they come to you and say, I'm really sorry, you're going to have to change the config again. And you go, oh, it's going to take me 3 weeks. I'll do it at home, just don't contact me. So centralizing config is really important. It also centralizes things like filtering and redaction. It also centralizes egress. If you're in a hyper-secure environment, you've probably not got access to the internet from your microservices. They have to go through something else. And when you say to them, I need all of my microservices to access this IP address, and they say, great, send us a form. And you go, okay, is it a Google form? And they say, no, fax it to this number. Centralizing egress allows you to be able to put a collector at the edge of your network, talk to your security team and say, that thing there needs to send telemetry to that thing there. And they go, just one thing. And then you're their best friend. So centralizing that egress allows you to be able to do it that way. It also allows you to be able to control it over things like private link and VPNs and express routes and all of those cool stuff. It also allows us to do filtering and redaction of information outside of your application. What it allows you to do is for every span that comes through, inspect the attributes, and if you see 16 contiguous numbers together, you're going to redact that because that's a card number and you shouldn't be sending it. That makes security teams happy. If you've got problems with your security team, talk to them about the collector. They'll love it. But it allows them to say, filter data, don't send these spans, do send these spans, redact this data, keep that data, these are the only keys you're allowed to send, and do that in one location, not inside your application. The other thing it allows you to do is enrichment. One really cool thing is if you're running Kubernetes, which by the end of the year will be the #2 project from the Cloud Native Computing Foundation, guess what's going to be #1? OpenTelemetry. It allows you to do enrichment with Kubernetes-based information automatically. So if you enable something called the KX attributes processor in the collector, and all of your services are sending their data through the collector, every single one of your spans will have a pod name. It'll have the start time of your pod. It'll have the deployment that it was part of, the replica sets that it was part of. It'll have the cluster name, the node name, and you don't have to do anything. And that's why it's really cool, but it will also do tail sampling. It's a really simple service. It's configurable by you, and you can do receivers. You can also, if you're using Jaeger at the moment inside your applications, spin up the collector. send your Jaeger stuff to the collector, and the collector will output it in OpenTelemetry format for you. Really cool. And that's me. Bang on time. Awesome. There's a QR code there. It's got some links. The repos will be on there. I do work for a company called Honeycomb. We are an observability provider. We do accept OpenTelemetry data. There's a free account that you can send 20 million events per month, every month to us for free. Do sign up. We did also literally write the book on observability engineering. It is free. You can download it. All the links are on the QR code. All the links from all the blog posts and stuff throughout the presentation are as well. There are some stickers at the front. Come take some stickers. I'm here for the rest of the week, so come and grab me, have a chat. I'm open to any questions, but not here because somebody's probably going to come on next.